So this video is going to show you how to calculate a Wilcoxon signed ranks test, which is obviously a requirement if you're studying A-level psychology. Now this is made for the Edexcel specification, which does require you to calculate the statistical test within the exam. Now, we've gone over this. There's a separate video on Introduction to Inferential Statistics if you want to have a look at that. But we've had a look at this table and said that we do need to know it because we need to know that when we create, or when we calculate, a Wilcoxon test, is when we've got a repeated measures design using ordinal or interval data. Now, we said that the confusing thing is that actually in these situations, both MannWhitney U and Wilcoxon use ordinal data. You need to know that the difference between them is that a MannWhitney U is an independent measures and a Wilcoxon is a repeated measures. And my little rhyme to help you do that is if you try and remember that Mr. Mann, Mr. Whitney and Mr. Wilcoxon are doing an experiment, Mr. Wilcoxon has always got an X in his name and he is cross, he's angry because he has to do both conditions because he's the repeated measures. So he therefore has to stay there all day, whereas Mr. Mann and Mr. Whitney get to go home because they're independent measures, they only do one condition. Now, Wilcoxon is actually, in theory, the best one that you could possibly get on your exam because everything you see on the screen here, obviously apart from the yellow box, is given to you on your exam. So actually, I don't know why, but for Wilcoxon, they literally give you instructions from the start to the finish as to exactly how to finish this. Not only do they give you instructions, they actually give you warnings about common mistakes or misconceptions and things to look out for. So please don't forget the minute it asks you anything to do with any of the maths or any inferential statistic, those first kind of 10 pages of your exam paper become the Bible. So make sure you go back and use those. Again, your critical values table, it's nice and straightforward for Wilcoxon. It's not quite like MannWhitney, this one. It's a lot more straightforward, but it even tells you down here the calculated value must be equal to or less than the critical value. So again, they're being quite nice really with the information that they're giving you. You just need to remember to look for it. Okay, let's do one together though so you understand exactly what you're doing. So within the exam, it's obviously repeated measures, so you'll see here each participant has two sets of data because they've done both conditions. So participant 1 here has done whatever condition 1 was, and then they've done whatever condition 2 is, and they've got 2 scores here. The first thing that we do is we have to find the difference between the 2 scores that each participant has got in each condition. Now the easiest way to do this is we're just going to take away the score from B away from A. I've done this for you. So you can see here, for example, you can check my working out in the first view just to see what it is that I'm doing. So I did 11 take away 8 for participant 1, which gives me a score of 3, 7 take away 7 for participant 2, which gives me a score of 0, etc, etc. You will see I've got some negative values, for example, down here for participant 6, because they actually did better in condition 1. But again, if I do 8 take away 9, it's okay, it just gives me a value of -1, which I'm actually going to ignore later anyway. Okay, the next stage here, this is the complicated bit. What I have to do now is I have to rank these differences. Okay, now I miss out any value of 0, and remember I said it does actually give you a heads up about this on your exam paper, but I'm going to miss out any value of 0. So like here, you'll see the difference was 0, so I've just missed out that score. You should also be ignoring all positive and negative signs. So again, here I've got a score of 1 and a score of -1, but I've treated them exactly the same. I've treated them as a value of 1 because it doesn't make a difference really which condition they did better in this situation. It just matters that there was a difference within the ability of conditions. So you'll see here, my smallest scores are always given the lowest rank. So for example, because I've missed out 0, my smallest scores then are my 1 and my -1, which remember I'm treating the same, so I'm treating them both as 1. So because I'm going to treat them both as 1, I've got 2 values with the rank with a score of 1. So remember I said on the MannWhitney video, imagine 2 people came exactly tied on sports day for first place. You can't just flip a coin and say, oh well, you get first place then and you get second place, because whoever gets second place would be really irritated. So what we have to do is we say, right, okay, well if you came first and you came first, 1 add 1 is 2. 2 divided by the 2 of you that we're talking about will give you each a rank of 1.5. So I've done position 1, I've done position 2, so the next smallest number then is going to be up here, down here, sorry, which is -2, because remember I'm ignoring the negative, so you're going to get position 3. Then again, the next number is number 3, so you're going to get position 4, etc, etc. Now when I've done that, the next thing that I need to do is calculate the sum total of the ranks for the positive difference and then the total of the ranks for the negative difference. So if we just put my table back on the screen, I've tried to colour code this to make it easier for you. So the first thing I'm going to do is sum, which we know means total of the ranks that I've just worked out for positive. So I'm going to go down my difference column and I'm only looking at the positive numbers. So you'll see that any number that's positive I've put in yellow so you can see the rows that I'm looking at. So all my positive differences, what I'm going to do then is I'm going to take their ranks that I've just given them, which are these numbers in the right hand column here, and I'm going to add them together. And once I do that, you can see my working out, I get 40.5. Again, I've put them in green this time so you can see the difference. Now I'm going to add together the negative differences. So wherever I had a negative number on the difference rows here, so I had -1, -2, I'm going to add together their ranks, so 1.5 and 3, to give me the negative differences, which is obviously 4.5. Again, it does tell you this on the exam, but the t-value is always the smallest value. Well, I've just worked out 40.5 and 4.5, so obviously 4.5 is the smallest number. So at the bottom of my page, where it's going to say t equals on an exam, I'm going to write 4.5 on there. So I'm going to show the examiner that I understand that t is the smallest value that's calculated. Now that's it in terms of calculating the statistical test, but we've got to prepare for the fact that the next question will probably say, are the results significant then using what you've just worked out? And to do that, we need the critical value table. So we go back to our paper, because everything we need is given to us in the exam, and we look up the critical value table for the Wilcoxon's test. Now remember, N in psychology just means number of participants, and we had 10 participants, so I'm going to go down to N to 10. Up here as well, you need to identify whether you've got a one-tailed or a two-tailed hypothesis, and obviously that tells you then which level of significance you're going to use, but it will tell you that in the exam. So it will say, are your results significant for a one-tailed hypothesis at the level of 0.01, in which case you're obviously looking at that one. I'm going nice and standard here, so I'm going to do a two-tailed test, and I'm going to imagine that I've got 0.05, because we know that that's the baseline, that's the standard for psychology for my 10 participants. So I go down, I go across from 10, and I can see that my critical value here is listed as 8. Now remember, the rule is exactly the same for all the statistical tests. If there's an R in the name of the test, then I need my calculated value to be more than or greater than or equal to. And if there's not an R in the name of the test, then I need my calculated value to be less than. Is there an R in Wilcoxon? No, obviously not. So actually I need my calculated value, the one I have just calculated, to be less than the critical value in the table. Well, my calculated value, the one I just worked out, was 4.5, and my critical value, the one I just looked up, was 8. Well, 4.5 is less than 8, so I'm going to write this up by saying the t-value of 4.5 is less than the critical value of 8 for a two-tailed test. Therefore, our results are significant, and I'm going to state that level. I'm going to say at the level of p is less than 0.05. Just very quickly on this, there's been an exam question on this before, Teddy and Chanel. The first thing students had to do was work out the mean. So they were given two different tables. They had to work out the mean number of words that were recalled in the left ear and then the mean in the right ear. And then just very quickly, they actually gave them this table where these three columns were done. So again, if you look at what we've just learned, they gave them the information for each participant for the two conditions that they sat. We worked out the difference in the rank. No, actually, I think they gave the difference in the rank, if I'm remembering this rightly. I apologise. You just had to complete it. And then here what we did is we said, right, well, that's a negative number, so I'm going to give it the rank. These are the positive numbers, so I'm going to give them the rank, but you'll see that they're actually all ranked together. Then we had to work out the totals, and then down here we got our final mark for identifying. Remember that t is the smallest value. And if you want to have a quick look at this as a mark scheme, please feel free to pause the video and have a look. Each point here is where the marks came from. Okay, it's 4 marks. Each one of these, 1, 2, 3, 4, is your 4 marks and how they were allocated.